Hello, I am Pankaj Sharma. Today we will understand how an AC generator produces electricity and why the current keeps changing direction. An AC generator converts mechanical energy into electrical energy. It works on the principle of Faraday's law of electromagnetic induction. Inside the generator, there is a rectangular coil placed between the north and south poles of a magnet. When mechanical energy rotates the shaft, the coil begins to rotate inside the magnetic field. Now, imagine this carefully. The magnetic field lines are fixed in space, but the coil is moving through them. As the coil rotates, its sides cut the magnetic field lines. Because of this motion, the magnetic flux linked with the coil keeps changing. And according to Faraday's law, whenever magnetic flux linked with a conductor changes, an electromotive force, or EMF, is induced. This induced EMF pushes charges through the circuit and produces current. Now let us understand the mathematics behind it. Consider a coil having N turns and area A. It is placed in a magnetic field of strength B. The coil rotates with angular velocity omega. At any time t, the angle between the magnetic field and the normal to the coil is equal to omega multiplied by t. The magnetic flux linked with one turn of the coil is equal to B multiplied by A multiplied by the cosine of omega t. Since the coil has N turns, the total magnetic flux becomes N multiplied by B multiplied by A multiplied by the cosine of omega t. According to Faraday's law, the induced EMF is equal to the negative rate of change of magnetic flux with respect to time. When we differentiate this expression, we obtain EMF equals N multiplied by B multiplied by A multiplied by omega multiplied by the sine of omega t. This is the expression for instantaneous induced EMF. The maximum value occurs when the sine function becomes equal to 1. So the maximum EMF is equal to N multiplied by B multiplied by A multiplied by omega. Now let us understand why the current keeps changing direction. At the starting position, the rate of change of flux is 0. So the induced EMF is 0. As the coil rotates toward 90 degrees, the rate of change of flux increases. So the EMF increases. At 90 degrees, the rate of change is maximum. So the EMF is maximum. After half rotation, the direction of motion of the sides of the coil relative to the magnetic field reverses. Because of this reversal, the magnetic force on the charges also reverses. And when the force reverses, the direction of current reverses. So during the first half rotation, current flows in one direction. During the next half rotation, current flows in the opposite direction. This continuous reversal produces alternating current. If we draw a graph of EMF versus time, it forms a smooth sinusoidal wave. The EMF becomes positive for one half cycle, negative for the next half cycle, and this pattern repeats continuously. Now there is one important practical question. If the coil is rotating continuously, how does the current reach the external circuit? The two ends of the rotating coil are connected to circular metal rings called slip rings. These slip rings rotate along with the coil. Stationary carbon brushes press gently against the slip rings. The brushes collect the current and transfer it to the external circuit. Because slip rings allow continuous rotation without reversing connections, the output remains alternating. And that is how an AC generator works. Thank you.